So today we're going to look at the hydrological cycle. Of course, you'll probably know this as the water cycle, but it's a little bit more complicated when we get to the IB level. So we've got some examine question here, we've got a discuss question, and we've got an explain question. Now, of course, you know exactly what examine means off by heart, but let's rephrase that question. What it's asking us to do is consider the hydrological cycle in a way that uncovers its assumptions and interrelationships. So let's have a think about what those assumptions are. The assumption is that the hydrological cycle is a closed system. That means very little water enters or leaves the hydrological cycle at a global scale. Okay, fair enough, we have a little bit of water input by meteorites, and we have some water inputted to the system by volcanoes, but effectively it is a closed system. However, of course, it's not totally closed because we do have solar energy, sunshine, entering into the system. So it's a closed system, but it's not a system that's in isolation. Of all the systems on planet Earth, the hydrological system is actually one of the most closed systems that you could possibly hope to come across. But perhaps more importantly, the system is in dynamic equilibrium. And we'll have a look later on what exactly dynamic equilibrium means, but you can click these links here for a closed system and dynamic equilibrium for more details. So there are interrelationships. You will see, looking at planet geography, the bold terms, and on the next slide, that there are lots and lots of parts of the hydrological system. And these all join up together, and they're all linked with each other. You can't change one part of the system without affecting the other parts, so they're all interlinked with each other. Dynamic equilibrium, that means the system is constantly changing all of the time, but overall, over a long period of time, let's say for 10 or 20 years, it's actually quite stable, but on a day-to-day basis, it may appear to be very, very unstable and constantly changing. So as we said before, there are different parts, and you will see that there are inputs, outputs, transfers and stores. In front of you you can see some basic terms, but I'd like you to have a look at planet geography and maybe go into Wiki to try to expand your vocabulary about the number of inputs, outputs, transfers and stores you've got. And prepare yourself for the lesson, because we are going to have a little game of either taboo or Pictionary. If you don't know what taboo or Pictionary is, have a click of these two links here. There's taboo, there's Pictionary, and we'll be playing that in the lesson. Of course, it is part of a system, and you can see here that you've got the hydrological cycle, but again, this is at a very basic level. I would encourage you to perhaps print off a copy of this and add your own additional terms to this from the book. Here we've got a really nice little video from NASA. One thing that you could do is, using those extended key terms from Planet Geography or from Wiki or your Pictionary game, you could add your own voiceover to this video. You can do that in videonote.es or you can do that in Vocaroo. Quite a nice thing to do. The video is really cute and it lasts about 90 seconds. So, we're also going to need to discuss the causes and consequences of the changing balance between water stored in oceans and ice. So this is to offer a considered and balanced view, which looks at a range of, for us, mainly a range of factors. Your conclusions, of course, should be presented clearly with appropriate evidence. There's a short tutorial page courtesy of another website. I'm not claiming that it's my own work. Please click there to see what the tutorial is, and that will help you to understand this balance between the amount of ice that we have on the planet and the amount of liquid water in oceans. Here, this video, Earth Underwater, it's 45 minutes. You don't have to watch it at all. Certainly you don't have to watch it all the way through, but have a quick look at that video, and if you want to, make some notes using Video Note. But I wouldn't suggest that you watch the whole video all the way through unless you really want to. There are some questions here for you to have a think about, and we're going to be answering those in class together. There's also an extra reading there on the New Scientist, and indeed they will help you to answer these 3 questions. Again, they're not my questions, they're from another website, so please click on the website to see the original document. I'm not claiming that that is my own work. The other thing that you need to do is you need to explain the concept of maximum sustainable yield, and we'll be coming back to this again and again. So, water is a resource, and if we extract it from the river basin, we can carry on extracting it until there's none left. Basically, the maximum sustainable yield means the maximum amount of water we can pump out of the ground before we run out. If you pump out more water from the ground than going into it, eventually, of course, being a finite resource, you are going to run out. There again, that concept of finite and infinite coming in again. There's a more detailed definition of what a sustainable yield is. You can have a read of that. I'm not going to read it out for you. Maybe you want to pause this video so you can have a read of that yourself. Okay, so I hope you paused the video and had a read of this little section here on what a sustainable yield is. The thing I'd really like to draw your attention to is links to other parts of the syllabus. Of course, the maximum sustainable yield will be affected by factors such as the universal soil loss equation. Also have a think about biodiversity, and also we've talked about ecosystem services. So please, can you go onto your Google Drive, find your Google presentations that you've stored yourself where we talk about the universal soil loss equation, biodiversity and ecosystem services, and link this document through to your own Google document on your own Google Drive. Okay, that's about it, guys. We've kept this one as short as possible. As always, there are additional videos for you to watch on the YouTube playlist, and there will also be a chance for you to add your questions to Google Moderator. Remember, as always, if you like the question, give it a tick and it will work its way to the top of the list. If you think you're in a position that you can answer that question for another student, please post your answers, or indeed another question. If you don't know the answer, you can always post another question in response to what the student is saying.